A warm good evening to all. I am Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. Uh, in this month, we are going to have a lecture series on heat treatment, which is predominantly used in metallurgical areas to alter or to change the mechanical property of any material. For examples, for steel, cast iron, aluminium, copper, nickel, etc. So this heat treatment is nothing but a controlled process which is used to alter the physical and sometimes chemical properties of a material, typically metals or alloys. It involves in heating the material to a specific temperature and then cooling in a controlled manner. The purpose of heat treatment can vary depend on the desired outcome, but there are some common objectives as well. First one is annealing. So now we are going to see the types of heat treatment. First one is annealing process. In this annealing process, the heating material to a specific temperature and then slowly cooling make it softer and ductile. So here I have to say there is a you can say taking the time and temperature in a graph, time at x-axis and temperature to y-axis. You can draw an inverted, you can draw a line like this. The first one, it is heating a particular sample to a temperature. We can hold the sample, holding, the second part is holding, we can hold sample at a particular point, at the particular temperature for some time, and then you can cool. So the first one is annealing, where as I already said, we are going to heat the material inside the furnace, and it is here the cooling is very slow, which makes the material softer and more ductile, as well as it relieves the internal stress and improves measurability. We'll see the different types of heat treatment in upcoming videos. The second one is hardening, heat treating the material to a critical temperature and then rapidly cooling. Rapidly cooling means here rapid cooling states that we are going to cool the material at a rapid range by soaking it in a cold water or brine solutions, etc. So that the cooling happens at 100 degree, 50 to 100 degree or more than 100 degrees Celsius per second. Means the temperature loss will be vigorously high. So rapidly high. So So due to this rapid cooling, it increases the hardness and strength. This process is often used for steels and other ferrous alloys. And coming to tempering, reheating a previously hardened material to a lower temperature and then cooling it, which reduces the brittleness and internal stress while maintaining the hardness and strength. Tempering process is just like a twin for hardening process. We never do the hardening process a single. Most probably we do hardening. After the hardening, we will do tempering. And the fourth one is normalizing, heating the material to a specific temperature and then cooling it in air. In this, if we see annealing, here the cooling takes place in the furnace itself. Means that the slow cooling is possible. Hardening, it's as I say, it's a rapid cooling where the cooling rate is very high. Here normalizing, the cooling is happening at there. So when we compare, the cooling rate is much higher in hardening, and then tempering comes into the picture. Hardening and then normalizing and then annealing. Coming back to normalizing, in a specific temperature and cooling it air and to refine the grain structure and to improve the mechanical properties. The last one is quenching, rapidly cooling the material in a quenching medium such as oil or water air to achieve specific properties like hardness and strength. So the heat treatment is crucially done in very many industries like automotive industries, aerospace industries, constructions and manufacturing, as well as it allows engineers and manufacturers to tailor the property of material to meet the specific performance requirements. For example, if I need a steel for which the property should be altered or tailor made so that it can be converted into even a wire or sheet. But basically the steel cannot be converted like this, but It is possible with the help of heat treatment. So this heat treatment plays a major role. A very simple example of heat treatment is that we are cooking, if we boil the egg and potato in water, we can see the egg is softer before boiling, but after boiling it is harder. The potato is harder before boiling, and after boiling it becomes softer. So this is the better example of heat treatment. That's all for today. Thank you. Have a great day.